So, my name is Bastian Schäfer. I'm representing here 52 North, an open source company located in Münster. And the work I'm going to present today was conducted together with our partners from University of Dresden, in particular Matthias Müller and Stefan Mees. So, what I'm talking about today. I want to leave the Inspire orbit for a while and have a look through our telescope on some of the next generation approaching problems and solutions that Inspire could face. So let's leave all the problems we have and all the solutions we know about Inspire right now and jump on to some of the next generation challenges. So this is one of the next generation challenge. I guess we are entering a new era, and it's not the Stone Age. It's probably you've heard this buzzword before, and at least what I observe is, if I read through magazines, the literature, observe what is going on in the community, that data is piling up. We are getting more and more data from sensors, for example. The satellite I showed before, the first slide, is also a sensor in cars, sensor in clothes, sensor everywhere. So sensors are one source of data, but there are other sources coming from official administrations, for example. And this data is piling up, and one term for this could be this big data term, which is a big buzzword in mainstream IT, but could be also a buzzword in our GI domain here. So again, we still have this, well, more or less huge amount of data, which might approach one day the Inspire Spatial Data Infrastructure, and we have to think about how to deal with that. So, well, here's another picture. It's not a mountain. As you can see, that is at least my perception of that mountain. It's nice to have all this kind of data, and it's even nicer to have this large amount of data, but like these stairs, there's something missing. So you have a stair and you have a railway, that's all fine, but something is missing. This is a door, and this is the door to information. So someone has to turn this large amount of data, this big mountain of data, into some useful information. So, and this is at least, this is my understanding, missing right now in Inspire. It is totally focused on data. This is fine, and someone can turn data into information in an offline step, but there are other ways to deal with that. And as I said, I want to talk about new challenges, so this could be one novel challenge. As you might know, there are ways to deal with that. Here's an OGC service. Could be a baseline for an Inspire service, which is in an online fashion, turning data on the left side into some information on the right side. This is all nice, okay? There is a solution already out there, what I'm talking here, okay? But I'm still talking about this large amount of data, and I'm talking about what is behind these processing services. And in these projects we are engaged, so this is us, 52 North and University of Dresden and others, we're dealing with scientists. And these scientists, like this guy here, what they typically do in the GI domain is modeling. So they have models. One model here for land use is, they have economical models, and they have some climate models, and they all go together with another model and predict, for example, the harvest of potatoes. Could be is one real example that we're dealing with. And they all need lots and lots of data. For example, to predict this harvest, you need time series of satellite data, you need sensor observations for all these climate models, and so on. So this is another model, climate change models, we all know these ones. Okay, and these guys, these scientists, are using tools. Some examples of these tools are graphical modelers, or you use some scripts, or you use programming languages, or whatever. So there are also different ways to deal with these models. But what we observed is that they typically stay in their office, like this guy here, and he's still playing with his data on his desktop machine as it is here. So the step of, well, now we have all this online information, even in a spatial data infrastructure like SDI, there might be even more data, this big data, but they're still doing this processing step somewhere offline in their own office. And Inspire is now about exchanging data in an interoperable way, but one next step, one next idea could be to also exchange models, like these models we've seen before, and change these models, or simple geoprocessing functionality, if you view a model as a single geoprocessing step. Okay, as I said, there is a way to deal with that. There is some standard for doing that. It's called Web Processing Service, and it's like a power outlet. It's standardized, and as long as you're following the standard, for example, me, I can use my German power plug and plug into the Turkish power outlet here. No problem, interoperability. So there is a way to doing that, but the problem is that when we are approaching this era of big data, that typically it is a one-way process. And the one-way process means here that the data is processed in an offline step. Well, we can do it in an online step with this web processing service, but it's still somewhere else. So it's in the valley. We have this big mountain, but the processing takes place in the valley. So one idea that is floating around since some time is not taking this big amount of data to the processing side, meaning terabytes of data, think about satellite data, to the processing side, but doing it the other way around, so bringing the processing facility somewhere to the data, so on top of that mountain, to speed up the process and eliminate the overhead of transferring terabytes of data over the web. Okay, so this is the idea, and we thought about, well, what kind of implications might that have? And we have this basic publish, find, bind pattern we all know, and which is also fundamental for Inspire. We all know how that works. But if we're talking about bringing the process to the data and not the data to the process, something might change here. So what we thought of is, well, we still have a data provider, or we still have a provider of a processing functionality, which is processing its functionality. But in that sense, it's not publishing a service, but it's publishing the model or the algorithm itself to some sort of catalog. We call this feed here. And the user can find it and can bind it, and bind means in that sense download it to its machine or to its processing facility and execute it close to the data. And these feeds I'm talking about have some layers, and we dig into that technical side here. So they're self-descriptable. We use the web processing service as one example of a host environment to execute these algorithms and models. And they have 4 tiers. One is, well, the functionality itself. Of course, it has to have some functionality. Then it needs some platform, for example, some operating system or a Python environment, whatever. It might also need some third-party libraries that could also be used for that, and it might need some hardware. Think about GPU processing, where you have algorithms specialized on GPUs. GPUs is the graphical computing engine, not your CPU. Okay, so we have these feeds, and it could get even more technical and more internals here. So we download it to one of our processing services to do it in an online step here, and it has the standard process description telling you what this process can do, what it cannot do, and there is an extension to it, the green box here, which is dealing with all the dependencies and the other layers beyond the functionality. And these non-standard functionalities describe the dependencies. So feed automatically knows it needs a Python environment, it needs an ESRI environment, it needs an intergraph environment whatsoever. And we thought about, well, is a catalog the right place to do this, the technical side? And a catalog works that typically that you register a service. But we're not talking about services anymore, we're talking about feeds or algorithms or models that we want to transfer close to the data. So the idea was, what is around which works similar, and we came across this AppStore idea, which is prominent for your mobile phones. And, well, there is some sort of competition, so you have different apps, in our sense models or geoprocessing functionalities, doing the same things, but they might compete on different levels, price, functionality, speed, whatsoever. And there is some central marketplace for that, and it's easy. The entry hurdle is quite easy. So you have to follow some rules and you can enter to that. So why not apply that to our ideas of feeds and bringing the process to the data and not the data to the process. So here's an example of an app store. Unfortunately, we have not finished the project yet. We would like to finish it, but, well, as you know, sometimes these software projects take longer than expected. So this is an example of an Android App Store, and you have different images about certain functionality. Think about these are different models that persons can upload and others can download to their processing environment. And if we look at the principles of these app stores, well, typically you have an easy search. What I experience about catalogs, it's quite complicated. You type in something and you have 20 fields to enter. This is different here. You can directly select in a graphical way, and you can download it. Of course, this is one of these principles, and you can upload it. And there is also a review system typically attached to it, ratings, test data, and updates. So these generalized features, generalized again, there is some user friendliness in two ways, download and upload, and there is also some quality aspects going on with that, review system, test data, and so on, updates. So applied to that, applied to our publish, find, bind pattern here, we thought about, well, let's exchange that catalog idea with these App Store principles. Meaning we apply these ideas to a catalog and call it App Store. So you're not registering services anymore, but you're uploading algorithms, geoprocessing models. And in the end, it would look like this. So you could download your apps, your geoprocessing functionality models to your local environment, which is this cloud here, where you have your own processing functionalities, your own host environments. One example is a web processing service as a host. Other environments could also follow this principle. And you have full control over that. So you know what is going on there, what capacity you have, what the resources are, which resources are free. You know when they are down for maintenance, and you don't rely on others. So typically what I experience in 50% of the cases, I want to access a remote service which is not under my control. It's either down or slow or something happens to that. So this is also eliminated with this idea. So this is the first screenshot of what we produced. It looks complicated, but it is not. So this is only if you generate some feed. So if you're a producer of a model and you want to register it with a catalog, in our case an app store, you have to enter some metadata of it. The important part is here to the left, down left, where you have to define the dependencies. So when you download one of these algorithms, automatically your host environment knows, okay, I need also a Python package 2.5 something. And if I have it, I can download it and I can access it. If I don't have it, well, I cannot access it. So this is not that you download something and then it doesn't work. So it knows it in advance. And this is also a first screenshot of our administration console. Well, what you can do is you can at least register some of these app stores, and what is missing is still a browsing functionality. And, well, it should look like this in the end. Browsing functionality where you can see icons and not only register URLs to it, and then download automatically one of these apps and register it as a new process in your web processing service. And once it is registered as a new process, you can access this new process like any other process that is already running on your server. So summarizing all this, well, the basic idea was bringing the code to the big data and not the big data to the code. And we talked about how this applies and which implications it has on the publish, find, bind pattern. We experienced that the catalog pattern probably doesn't apply, so we exchanged it with an app store idea, which has certain advantages like speed, security, trust, control over your resources. And at the end, we want to try something which is user-friendly and quality assured, as you see right now, for your app stores on mobile phones. Okay, so this was a quick look through our telescope on one of the new ideas and approaches that could happen in the future for an Inspire SDI. Thank you.